Assalamu alaikum everyone. Today we are going to talk about research on network and device forensic analysis of Android social messaging applications. Introducing the concept of device forensics to you. Digital evidence can be collected from smartphones, specifically the instant messaging applications. The phones may have evidence that may help in criminal investigations or court proceedings, and they are always kept in close proximity by the people in this day and age. SMS or the text service has been kind of outdated as these instant messaging applications have become very popular. They provide a very low cost and efficient alternative. They provide additional features and services too, which include sending pictures and videos or doing live calls or sending documents over the network. The research provides an experimental study on 20 popular social messaging applications for the Android device. The evidence from the apps is collected using the image of the device and getting database information. It is collected from data in transit over the network and the data stored on application server sides as well. The issue that this paper covers is that these instant messaging applications have to address the privacy concerns of the users. And they have to eliminate all the vulnerabilities so that the user's data sent or received must be kept confidential. These vulnerabilities are actually very useful for forensic evidence collection, and eliminating the vulnerabilities will also eliminate the possibilities of collecting digital evidence from those apps. The paper tries to find the popular apps that allow the collection of digital evidence in any way, also highlighting the security concerns that need to be addressed for each application.
Now let's move towards the methodology of the research paper. So basically, instant and social messaging applications from Google Store were selected. The selection was based on the popularity of these apps. The exact metric was that a particular social messaging app has over 500,000 downloads, then it is suitable for this research paper. Furthermore, only those apps were selected that provide one-to-one correspondence. Next, keyword searches were conducted to carry out the forensic experiment, and the specific keywords were chatting, dating, and messaging. Continuing with the methodology of the research paper, the primary device used in the experiment was an HTC One M8, whose Android version was 4.4.2. For the secondary device, an Apple iPhone 2 was used, whose operating system was iOS with the version 7.1.2. The lab environment was also set up. All 20 apps under investigation were installed in both the devices, the primary and the secondary device. Network forensics were conducted on the messages being sent and received over the network, and furthermore, Android device forensics was also conducted to retrieve further information. The setup of the experiment looked somewhat similar to the diagram on the right. Both the devices, the primary and secondary device, are connected to a Windows 7 access point using virtual Wi-Fi mini point adapter feature. The exact video experiments are shared on the link given on the left. Messages of evidentiary nature were both sent and received on the target device over the network. Different types of evidentiary messages were used. These included plain text messages, picture messages, and video messages. Activity traces corresponding to these messages were documented if and found. After carrying out network analysis, the device forensic analysis were carried out by imaging the device. The unencrypted evidence was searched for in the database files. Application servers were also searched for unencrypted server-side media.
Two types of tools were used in conducting this research. Number one, network forensics analysis tools. Number two, device forensics analysis tools. The network forensics analysis tools involves network miner, Wireshark, and net witness investigator. The network miner and Wireshark were used to observe the live traffic, while the net witness investigator was used to analyze the network traffic obtained from the earlier mentioned tools using PCAP files. Moreover, the data storage or the device forensics analysis tools involved XRY, Helium backup, Android backup extractor, and SQLite DB browser. The XRY tool is used to get logical acquisition of the Android device. In order to cross-validate the results obtained from the XRY, the researchers also used the helium backup to get a logical acquisition of the device. In order to read the logical backup obtained by the helium backup tool, Android backup extractor tool was used, and to read the database files that were generated using helium backup and XRY, SQLite DB browser was used. This section encapsulates the results that were obtained after conducting the research. It presents a table that includes the applications, their capabilities, and the perform activities, followed by the results that were obtained. Out of 20 applications, only 4 applications were found to have no vulnerabilities inside them. It included Tinder, Wickr, Snapchat, and VPN. It is because these applications encrypted their network traffic, data storage, and server storage at all times. For remaining 16 applications, the researchers have furnished their research in the form of a table that is present in this slide and the next slide. The table consists of a number of columns, for example, applications, capabilities, performed activity, network traffic traces, data storage traces, and server traces. These traces are obtained using a number of forensics tools that have been discussed earlier. Moreover, a number of applications are vulnerable to network traffic traces, for example, WhatsApp, Viber, Instagram, Occupid, Ovo, Tango, and Cake. These applications exchange their data from one end to another end, and that can be very easily intercepted using the forensics tools for network. For the data storage traces, the application Ovo and Kik can be categorized as these applications store local backup on the devices, and they can be easily read as they are not encrypted at all. For the server traces category, we have Viber, Instagram, Ovo, and Tango. These applications exchange a URL from the server end to the client end, so that client can deposit data on those URLs that can be further transmitted. Unfortunately, those URLs remain active for a number of days, and they can be very easily intercepted or captured by any forensics investigator, or for that matter any hacker, and can access the data present on those URLs. In this slide, we can see that there are a number of applications that are susceptible to the network traffic traces. For example, Limbus, Meet Me, Message Me, Text Me, Grindr, Haywire, Hike, Text Plus, and Facebook Messenger. All of these applications exchange their data, which can be easily acquired by any forensics expert. Going to the category of data storage traces, we can see that the applications like Nimbus, Meet Me, Text Me, Haywire, and Hike, as well as Text Plus, they store a local backup on the device without any encryption whatsoever, and which can be easily exploited by or obtained by any sort of computer forensics investigator or any hacker for that matter. For the server traces category, we have Message Me, Grindr, Haywire, Text Plus, and Facebook Messenger. These applications exchange a URL which can be easily obtained using network forensics tools, and these URLs can be opened to acquire the data that has been deposited from the client on the server. The researchers of this paper have concluded their research by stating a fact that overwhelming majority of applications do not consider user privacy as their topmost concern. Due to lack of focus on user privacy, the data that is exchanged over those applications can be easily extracted using a number of network analysis or logical analysis tools that are openly available. From a forensics expert perspective, the results of this paper are very promising. However, these loopholes that are exploited in this paper can be easily used by the black hat community for their nefarious designs. Moreover, the researchers of this paper also tried to contact the application developers so that the loopholes can be further minimized and the data of the users can be secured. However, very less number of responses were observed by the researchers themselves. This marks the end of this presentation. Thank you very much.